Okay, good morning everybody. This is Joe, K7JOE, and today we're looking at a old HealthKit SB200 that I picked up, and the SB200 was essentially unmodified. No modifications to it at all. The couple of quick repairs that I did is I replaced the caps on the power supply board, the high voltage caps, and put some computer grade caps in there. I used the original power supply board. We'll take a look at this once we open up the top to take a look at the cap replacement. The caps that I used were some computer power supply caps. Pretty good quality, 450 volt. I believe they're 220 microfarad. I had them in the junk box from another project, and so I just went ahead and soldered them on the board. The holes didn't line up exactly well, so I put some legs on the caps and then soldered them on, and seems to be working just fine now. I do have an inaccuracy in the high voltage meter. The meter is reading about 1900 to 2000 volts, and the actual voltage tested with the multimeter is about 2350. So probably some resistors in the meter sensing circuit have drifted out of value and are showing a slightly lower voltage. But it doesn't matter. Works great. Works fine. I had it on the air, doing a good job. The other thing I did is I put in a soft key relay system, and this is not the expensive Harbach system. This is a very inexpensive relay system. It's basically using an Arduino board, and you can buy these relay boards on eBay for about $3 a piece, and they run on 12 volts. And essentially you just bypass the circuitry that normally would key the amplifier, and you wire in series with the relay key jack, which is here. You wire in series this relay. So hold on a second, I'm going to remove the black tape so you can get a look at what this relay does. Okay, here we have the relay board. Again, this is just one of these Arduino-based relay boards. I mean, they're literally $2 or $3. You go on eBay and you can see them all day long. They make lots of different boards. They make a 1 relay board, a 2 relay board, a 5 relays on a board. Anyway, it's a 12-volt board. And so you're saying, well, Joe, how do you get 12 volts? Well, I don't have 12 volts in the chassis of the SB200. So what I did is I went into my junk box and I grabbed a wall wart, and I wired the wall wart in. So now I've got a wall wart in addition to the AC outlet, so I can use my soft key. Eventually what I'll do, I ordered, but they haven't arrived yet. They sell some very small little 12-volt modules, and I'll put a little 12-volt module in here right next to this. I guess I could have plucked 6 volts off of the plate line and rectified it, and then I'd have had, 7.5 volts peak to peak, and hoped it would have worked. But I know this works. I guarantee this works. Had this on. So anyway, it's just basically just wiring some simple connections from the relay jack. You've got 2 connections basically going into the input side of the relay, and you've got 2 connections coming out of the relay. One of those goes to ground, and I just pulled the ground off of this bracket, and the other connection goes basically to the back side of this resistor, which essentially triggers the relay. And I can just show you here quickly how does it work. So let me just show you real quickly here. Just got this little box here, and it's just a key switch. And I plug that into the relay, but this will simulate a modern radio, a radio that can't handle the AC voltage that is typically on the SB200 relay jack or relay line. So let me just show you again, just real quickly. Got basically 2 wires that come off the relay input line that's been cut, and they go to the relay in, and then I've got of course the in trigger line, the in ground, and then I've got my 2 black wires there. You can see them, a positive and a negative. The positive 12 volts is on that white wire, and the negative is on the black wire. That's the input. And then the output just basically loops back. It's a ground. That center conductor goes to, the center wire goes to ground, and then the upper conductor goes to a normally open relay line, and that just goes back through the wiring harness, back to back to this resistor here, the back side of the resistor. And you can basically see what I've done is I've clipped that resistor. That resistor used to go to the center pin of the relay jack on the chassis. I clipped it off, and so now the center pin of the relay jack goes through the relay, and then the output of the relay goes to that and triggers the rig. So let's just take a quick look here. Let me power this up. Again, it's just low voltage. And hit my power switch here. And what you'll notice is on the back side of this relay is a little LED. Bang. You see that green? You know that the relay is powered up. So that's my 12 volts. No, I can't see the LED directly, but I can see the reflection, which is good enough. Now when I key, what you'll hear is you'll hear a few things. Let me zoom out here. Watch the lower red relay down here. Okay, watch for a red light. And then at the same time, you'll see this relay close. Well, of course, I'm not powered up. What am I saying? I'm not powered up. Let me turn the amplifier on. Let me get some AC voltage there. Okay, so you can see clearly. Okay, the relay is closing. You hear that? Okay, now let me just stand by a second here. Got to make sure everything's clear and safe before I plug in, because I do have the chassis open. And let me hit the power switch on the amp, which is on. All right, here we go. And now, you can see that. So now we have a soft key. We don't have any AC on this line. It's no voltage, basically just a normally closed. It's opto-isolated, normally open relay. When you close it, as if you're keying your solid-state HF rig. There you go. $3 solution to an SB200 soft key relay system. $3, gang. No need to spend $30 over at Harbach, although I'm sure they make great product. Okay, this is Joe, K7JOE. We're going to continue on with some more modifications of the SB200 clunker amplifier that I purchased in order to use for Parks on the Air and for the QSO parties and maybe even out at field day. All right, K7JOE, back soon. Okay, here's a quick look at another couple of the mods that I did to the SB200 that I picked up. One of the things that you'll notice here is it's got some new power supply caps in there. They're not all matching, but they're pretty darn close. Got 4 of the computer grade caps, and then 2 of the taller caps. The values are the same, just a different size setup. So they spec out the same. The old caps were the old paper caps, and I was suspicious of them. They were going on 50 years old, so I went ahead and replaced these, and I'm getting proper voltage. High voltage out seems to be just fine. They're not the prettiest thing. You'll notice that the caps are kind of a little bit, well, they're not exactly mounted directly to the board. What I basically did is soldered on some copper legs to the base of the caps, and then the soldered legs solder onto the circuit board on the SB200, because there's just not enough clearance. I would have had to drill that circuit board, and I wasn't looking to do that. You could buy an entirely new power supply board with the caps installed for about $100 or so, and I've got about $15 into this solution. So again, just a very low cost solution. Try to get the old SB200 on the air. Again, the soft key was a $3 solution, and this is about a $16 solution here. So I'm in it for 19 bucks. Actually, I'm in it for 20 bucks because I spent $1 and I got a couple of diodes. Actually, I spent about 4 cents on the diodes, but you can see the diodes are placed back to back across the back side of the meter. A little bit hard to see here in the video because my hand is shaking, but I've got a couple of diodes. They're just, I don't know what they are, 2 amp diodes placed back to back, and you place that across the metering circuit, and that will protect the meter from burning out because the HealthKit meters are getting hard to find. That'll protect the HealthKit meter from burning out if you get a tube flash over. So that's also very, very cheap mod, very simple one that you can do. Cheap insurance. Okay, next we're going to go to the RF deck. Got a couple of Cetrons in here, and I'm going to swap some tubes around. These are okay. With 70 watts of drive, I'm getting about 400 watts out. So they're getting a little bit long in the tooth. They're still probably fine, and we'll probably have hundreds of hours remaining on them. But I'm going to swap some different tubes and see what kind of power output I can get. out of this old amplifier.